the next topic that I want to take up will be on free body diagrams. Which is in short they are called FBD, free body diagrams. Suppose we have say a pulley and we have two masses. This is mass M1, this is mass M2, and let us assume that M1 is greater than M2. So obviously this will accelerate down, this will accelerate in the upward direction. So this is body 1, this is body 2. What is the meaning of free body diagram? So if we are drawing the free body diagram of body 1, we will just mark all the forces acting on this body. Obviously one force will be the weight of the body acting downward, so it will be M1G. Another force will be the tension of the string acting on this block, which is acting upward, and the resultant effect is acceleration is downward. So this is the free body diagram. Show the forces, all the forces acting on the body and the direction of the acceleration. So we know when we write this equation, F is equal to m into A from Newton's law, remember this F is the net unbalanced force. It is the net unbalanced force. Because if the forces are balanced, then there will be no acceleration. So if there is unbalanced force, there will be acceleration, and obviously acceleration will be in the direction in which the larger or greater force acts. So because the acceleration is down, so this force is greater than this force. So what is the net force in the downward direction? So it will be M1G minus T is the net unbalanced force. So F should be equal to mass, here it is M1 times acceleration. So this is my fundamental. So this is for body 1. So if we do the free body of body 2, what are the forces acting? Two forces acting. So one will be the weight M2G, another will be the tension. Here we are assuming that the string is inextensible, the pulley is massless, and there is no friction anywhere. So those are the assumptions that we are taking. Because the rope is massless, the tension will be same, and the acceleration obviously here will be in the upward direction. So here if we write the equation, it will be T minus M2G. Net unbalanced force, obviously this T will be greater than M2G because the acceleration is in the upward direction. So T minus M2G is the net unbalanced force. That should be equal to Ma. So here mass is M2 into A. So this will be my second equation. So if this was equation 1, this will be equation 2. And see, there are two unknowns, tension and the acceleration, which can be solved simultaneously from these two fundamental equations. So this is one type of problem that comes on free body diagrams. Okay, let me move on to another case. The second case will be like this. Suppose this is M1, this is M2, and we are assuming that there is no friction between this block M2 and the table. No, there is no friction. So we are neglecting friction for the time. And the acceleration will be like this. So for body 1, if we draw the free body diagram, for M1, obviously, just like the previous case, it will be M1G, tension will be T, acceleration will be A. So my equation will be m1g minus t is m1 into it. So this is one fundamental equation. This is similar to the last case, but for body 2, here if you check, you have to be careful. Here 3 forces are acting. How? One is the weight of the body, which will be m2g. One will be the normal reaction. What is the normal reaction? Reaction on the block m2 by the table. So that will be in the upward direction. But we can understand that there is no acceleration in the y direction. There is no acceleration in this direction. Only the acceleration is in the x direction. And which is causing the acceleration in the x direction? That is the tension. So 3 forces are acting on block 2. The tension towards the right, weight acting downward, and the normal reaction acting upward, and the net result is acceleration in the x direction. There is no acceleration in the y direction. Because there is no acceleration in the y direction, we can straight away write n is equal to m2g. And in the x direction, only unbalanced force is T. So net unbalanced force is T, should be mass times acceleration. So this is my second fundamental equation. Because there is no friction, we will not be using this. Later on, if there is friction, then this n will come into the picture. Otherwise, we can use this. This is equation 1 and this is equation 2. So solving 1 and 2, we can get T and A. So be careful that the number of forces acting on M2, 3 forces are acting. So the directions, be careful. Normal reaction, normal means it is perpendicular to the surface. So if this is the table, so it will be perpendicular to the surface acting upward. And weight is acting downward, and obviously because of this M1 there will be tension in the string which will accelerate this block M2 towards the right. So that is why tension is acting towards the right. So these are the 3 fundamental equations, but for this case we need not use this. You can just make a note. If there is friction, then you will find that an additional force, frictional force, which will act towards the left, that will come into the picture. Okay, we can move on to another case. For all these problems, we are assuming that there is no friction present. If there is friction, then one additional force, which is the frictional force, will come into the picture. So we can have what is known as an inclined plane. If you have something like this. So suppose this is M1, this is M2. And we assume that the data is given such that M1 is going down and M2 is moving up. So, and there is no friction anywhere. So for M1, because we have already done in previous cases, the equation will be M1g minus E is equal to M1a. I am not going into the details of this, same as previous case, but let me do this case. This will be me. So FPD of M2, how many forces are acting on this? For M2, one force will be the tension in the upward direction, one force will be the weight in the downward direction, and one will be the normal force which is perpendicular to the surface. Surface means this is the surface, so it will be perpendicular to the surface. So this is M. Acceleration is along the incline. So if you resolve this M2g, you will get, this is T, because this angle is theta. This will be cos theta, this will be sin theta. So this will be m2g sin theta. This will be m2g cos theta. This is m. See, t and n, they are along the, we are choosing the axis, one along the incline, another is perpendicular to the incline. We are choosing our coordinate system along the incline, so t is along the incline, n is perpendicular to the incline. So we are not resolving these two. But wait, it is not along this axis. So we are resolving it into two different. This will be the cos, this will be the sine. This will be the cos, this is the sine. And the acceleration is in this direction. If you check, the acceleration is only along the incline. So perpendicular to the incline, there is no acceleration. So these two components must be equal opposite. So my equation will be n is equal to m2g cos theta. Because there is no acceleration perpendicular to the incline. There is only acceleration parallel to the incline. So because there is acceleration in the upward direction, this force must be greater than this force. So T minus m2g sin theta should be m2 into a. So this equation, you can call it equation number 2. So this is equation number 1, this is equation number 2. So solving these two, you can find T and A. I am again just emphasizing one point. For this, see, three forces are acting, N, T and M2G. M2G sin theta and M2G cos theta, these are not two separate forces. It is one force, but they are resolved along these two axes. That is why four terms have come. Okay, these two are not separate forces. This is, we are resolving the vector into two parts. One along the incline and one perpendicular to the incline. That is why these two terms have come. But rest of the things we are following just as if it is F is equal to ma. So net unbalanced force is mass times acceleration. There is no acceleration perpendicular to the incline, but there is some acceleration along the incline. For this case, it is up the incline. So we have got this equation.